Hello everyone and welcome to the Xojo webinar. I am Paul Lefevre, the Xojo Developer Evangelist. And for today we have a short and sweet webinar that hopefully you might be able to get a few tips from. We got a few slides, a couple examples, and I'll have some time for questions if we have any. So let's jump right in. Today we're going to be talking about some cross-platform tips that might prove helpful for you when you're working on desktop apps that need to run on more than a single platform. So the first thing I want to stress, because this isn't always obvious to people, is that you need to make sure you test in all platforms. Xojo makes it super easy to obviously build from more than one platform. You just go to the build settings, you check a little box next to the operating systems you want to create apps for, and you can just hit the build button and get all kinds of apps for different operating systems. And that's great. That's super easy. It's a major benefit of Xojo. But you're still going to want to test before you do those final builds. You're still going to want to test on the different operating system targets. Things can look different, and you don't want to just assume everything's going to look exactly the same across all the platforms and then end up shipping something that you never even looked at, and then you get bug reports or people aren't happy or that sort of thing. Right now, the current major versions of the operating system out there is macOS. Just came out with macOS Sierra back in September, and actually I think yesterday 10.12.1 was released. So that is the latest version of macOS that Xojo supports. It also goes back to Mac OS 10, 10.7. Apple loves to change the names of the Mac operating system, so it went from Mac OS 10 to just OS 10 to now Mac OS. So Mac OS Sierra is the current one. On the Windows side, the most recent version is Windows 10 Anniversary Edition that came out last, I think it was July or maybe August. And I generally recommend the 64-bit version at this point. It has all the necessary stuff in it to run 32-bit apps, should you still need to ship those, but it can also run 64-bit apps as well, so it makes it a little easier for testing both types of apps. On the Linux side, I continue to recommend Mint. And in this case, Mint 18 64-bit is a really great one to work with. First of all, it appears in my testing that Mint 18 64-bit also includes the 32-bit libraries that are needed to run the Xojo IDE and 32-bit Xojo apps without you having to install anything. So obviously that is really awesome, because sometimes on various versions of Linux, getting those 32-bit libraries installed can be a bit of a pain. But like I said, in my testing, which has simply involved downloading the Mint ISO files and installing them, everything just kind of runs right out of the box. It's almost like you're running Windows or Mac OS from that aspect. So it's Mint is a great, easy-to-use version of Linux and fabulous for testing. So how do you test all these things? Well, as you may know, I'm a big fan of virtual machines. I did a webinar earlier this year, probably in the May-June timeframe, on virtual machines and remote debugging and debugging in general, so you can check that out for more specifics. But virtual machines are a great way to have a bunch of different operating systems set up so you can test. And there are a variety of products that are available for virtual machines. I personally use VMware Fusion. Parallels on the Mac is also a popular choice. VirtualBox is freely available and can be used. I find it's a bit ugly and slow, but hey, it's free and it does get the job done. On the Windows side, there's also solutions from VMware as well. And I think there's Microsoft used to make something called Virtual PC, but I don't think they do that anymore. They might have another tool available on Windows as well. Of course, testing on real machines, if you happen to have multiple machines in your work area that you can refer to, is also a great way to test. You just need more space, obviously, for displays and keyboards and the computers themselves and that sort of thing. So virtual machines are great because they're easy. They don't take up a lot of space. You can have lots of different setups that you can turn on and off as needed. Virtual machines also, at least most of the products anyway, allow you to do something called a save point. So before you make a particular change, you can save the state of the VM, install different things on it, test around, and then restore back to the original point. So you kind of get a clean slate every time. And that is also very, very useful for testing purposes. And that's not as easily done using real hardware. And of course, in conjunction with all of this, the remote debugger. And I mentioned I did do that webinar earlier this year on essentially remote debugging in conjunction with virtual machines. So you can check that out for more specifics on how to use those things. But those two combined make a great way for you to do your testing, because essentially you can run Xojo on whatever computer you're comfortable using and use the remote debugger to run a test debug version of it on a different operating system. And I should also point out that you can certainly have multiple versions of each of these operating systems installed. In my case, I have multiple versions of Mac OS set up in a VM. And I will typically, when a new beta comes out or something like that, set it up in a VM first for testing purposes. The same thing with Windows. I have their Insider build set up as a separate VM, so I can test that out. That's kind of their beta process, so you can test out new features, make sure everything looks good. On the Linux side, you can, of course, grab most Linux operating systems for free just by downloading them, so you can set up a wide variety of Linux operating systems for testing, should you be so inclined. That can be a bit of a rabbit hole, because there are a lot of Linux distributions, and if you are the type of nerd that finds it fun installing different operating systems and playing around with them, you could get really sucked into that for a while. But multiple ones certainly are a great way to test things out. All right, so once you've done some testing and maybe you've found some differences that you want to account for, you can implement platform-specific code. Now, this is going to be code that runs only on the particular operating system target. Xojo has several built-in constants that can be used for this, and the main ones for the operating systems are target Windows, target Mac OS, and target Linux. And you simply can just use these in if statements to block out code that only is needed for one of these particular operating systems. So here's a quick example. So just, something simple like this. You can see I'm using the pound if and the pound else if, and those are the build compilation settings. So they will actually only include the code for the specific target in the executable. So if you're building for Windows, only the code that's in the if target Windows block will actually get included in your app. The rest of the code isn't even compiled at all. And you don't necessarily have to do that. You could just use a regular if then else if you wanted. But if it turns out the code is totally unnecessary on the different targets, you might as well go this route and have it, completely jettisoned from your build and make it, that little bit smaller. And you can do all kinds of stuff like this. Code that's in here can literally be anything. You could have your app in the app.open event start up with a conditional compilation block like this and have it open a different window, depending on whether it's running on Windows, Mac, or Linux. And then, those windows could be maybe even designed completely differently. Or you could just do something as simple as maybe look for files in a different location, depending on the operating system. Or anything in between. Really, whatever it turns out you need to do, you can handle it using these sort of platform-specific code with the target constants. Now, these aren't really related to cross-platform stuff, but I thought I would mention them here because not a lot of people even know they're there. And these are the compatibility flags. So you may have seen this if you go to the Advanced Inspector tab for something like methods, and you'll see this little section that says Include In, and it's got a bunch of checkboxes. And this just means that that particular thing you're working on by default is included in, whatever project type that you happen to be building. But you can uncheck those things to exclude it from certain things. And that's available for events, properties, classes, and modules. And I just wanted to point that out because it's not a commonly used thing, but a lot of people don't even notice it's there. So I just wanted to bring that to people's attention. Now, another thing you'll want to consider is your control layout. In particular, one common thing that you may have seen from time to time is the position of OK Cancel buttons. So, for example, you might have seen that on Windows and generally Linux, the buttons are laid out as OK and then followed by cancel, left to right. But on Mac, it's the opposite. It's cancel followed by OK, left to right. And people generally get accustomed to seeing the buttons in the order for the operating system they're using. So if you happen to be, using a Mac all the time and you use a lot of Mac apps and you design your layouts on a Mac, you're probably going to design your buttons so that they say cancel OK. And then if you don't switch them when you build for Windows, they're still going to say cancel OK. And some of your Windows users might find that confusing. Now, a good portion of Windows users maybe won't care. Windows apps tend to vary a bit more in their style than maybe Mac apps do. And certainly on the Linux side, there's not a lot of style there that is consistent, so maybe people there wouldn't notice. But nonetheless, it's pretty easy to swap them around depending on the platform. And there's a sample project that's included with Xojo. Here is the path. It's in the desktop custom controls, and it's called OK Cancel Container. And it's a container control. We'll look at this in a bit. That you can just drag onto a window, and the buttons will automatically flip around depending on which platform they're running on. Another thing to keep in mind is the size of the fonts on your controls. This can particularly be a problem if you happen to be building for Linux. Linux has a wide variety of themes for the user interface, and some of the themes have large fonts. So you could end up with the button text looking like you see here, where some of the text is cut off because the default button size is not big enough to hold it. Now, that button size would be perfectly fine on Mac or Windows, but then when you build for Linux and you run on Linux, you see that your text gets cut off, and that can be a little annoying. You actually can see this in a fair amount of the Xojo example projects, depending on the version of Linux you happen to use, because they don't really account for this. There is a project included in the Xojo examples in the platform-specific Linux folder, and it's called Get Default Control Size. And this uses some declares on Linux to ask the system UI manager what the default control size is for a particular type of control. And you can use this information to essentially resize your controls so that they will fit the text appropriately. This isn't some sort of automatic magical thing. You're only going to get back the size. You'll have to adjust heights, in code. Maybe reposition controls so that things still fit and look proper in your layouts. But it does give you the ability to end up with buttons that perhaps are a little bigger, but the text no longer gets cut off. All right, dynamic constants. These are a way that you can change values based on a particular platform. Now, you may have heard dynamic constants can also be used with localization. Yes, absolutely true. And that's probably where they are most commonly used. But they can also be used to just change, usually text, based on the operating system. And every, for example, default desktop project that you create with Xojo comes with some of these built in. So if you expand the app object in the project and look at the constants, you'll see that there are 3 in there. And one of them is called kfilequit. And you can see it has a default string value of quit there, it's shown at the top. And then it has an entry that says if the platform's Windows, and we don't care what the language is, change the value to be exit instead, because Windows apps in the file menu generally do not say quit, they say exit. In addition, the shortcut key constant has no entry for Windows, because in general the Windows exit does not have a shortcut key specified. But OS X, it's almost always Command Q, and on Linux, Control Q. So you can see these things will just be swapped out automatically when the project gets built. And you can do this for any constants you want to create. So if you have other text that needs to vary based on the platform, it could be maybe an error message or something like that, and you want different text depending on the platform it's running on. You can put that error message in a constant like this and have the different error message text specified by the OS platform. Now that's how those are set up. This is how you use them in the menu. So if you look at the file quit menu item, you can see in the text property that it is telling it to use the constant. So it doesn't have actual text in there. So it has the pound sign that's saying use a constant value, and then it has a reference to the constant. And in this case, the constant is on the app object, so it's app.kfilequit. And you can see it'll actually take the value for the platform you're on. So I took this screenshot on Mac, so it grabbed the text for quit, and that's what displays there. And if you go down a little bit to the shortcut section, you can see the key property. And it's set up the same way. app.kfilequit shortcut, and you can see there that it grabbed the Command Q shortcut, and that's what ends up being displayed in the menu. And if I run this on Mac, that's what I'll see. But if I run on Windows, I see the other settings. And you can use this sort of thing, the pound with a constant name, in any property that uses a text or string constant. So you could use it for button captions, default values, that sort of thing. All right, menus. Menus work a little bit differently across the platforms. And there's two particular menu item subclasses I want to point out. There is the prefs menu item. And the purpose of this is that it moves what would be the menu item for accessing your preferences in your app. And it's primarily used to move that menu item when your app is running on a Mac. Most Windows and Linux apps, you're going to find preferences is going to be under the edit menu, and it's probably actually not even going to be called preferences. It's probably going to be called options. So that is a good example of where you'd probably use a dynamic constant, so that on Mac, that text gets changed to preferences. And on Mac, the preferences are actually in the app menu. Now that's the leftmost, well, not the leftmost menu. The leftmost menu is I guess it is the leftmost menu. It's the Apple menu. And in there you'll see the preferences item. So what you generally want to do is you want that item to appear there automatically, but you can't manually add stuff there. So you just put your preferences wherever you normally would have it, and then you set its super to be prefs menu item. And it will move automatically when your app runs on Mac. Similarly, there is a subclass called application menu item. And again, it moves a menu item on Mac over to the application menu, and it kind of sticks them at the top. And this is often used for the about menu item. Again, Windows and Linux, you typically are going to find the about menu item for your app under the help menu. So help about is what you often see. But on Mac, the about is on the left menu. And by using this subclass, when your app runs on the Mac, that menu item will automatically move where it belongs and where people expect it. And related to menus, we have the auto quit property. This is a property of the app itself. And its default value is different based on the operating system. So on Windows and Linux, auto quit is true. And this means that the app is going to quit automatically when all its windows are closed. Now, if you think about that, it generally makes sense because Windows, all versions of Windows, the menu is actually attached to the window. So if all your windows are closed, well, your app is pretty much, you have no way to interact with it by default. So it makes sense that the app should quit. And this is also generally true on Linux, although some versions of Linux will tie the menu to the global screen rather than specific windows. But that varies a bit by Linux distribution. You can change this behavior on Windows and Linux. You can set the auto quit to be false so that your app does not automatically quit when all its windows are closed. However, if you do this, you still are going to want a way to interact with the app, right? Otherwise, you'll kind of have this phantom app that's running in the background that your user can no longer interact with. And you'll see that Xojo even has a way to do this itself. And a common technique is to maybe put something in the tray item, in the system tray, that lets you interact with the app that's still running, even though there are no windows that you can access. And Xojo has a preference on Windows that allows you to keep Xojo running if all the windows are closed, and there'll be a tray item icon that shows up that from there you can create new projects and do stuff like that. When you're on Mac, the auto quit property defaults to false. And this is because apps remain open when all the windows are closed because Mac has a global menu that is displayed at the top of the screen and is not directly associated with any specific window. So when all your windows are closed, you're still going to have the menu for the app itself displayed at the top of the screen until you switch to another app. This is pretty common behavior for most Mac apps, but it is not the rule by any stretch. There are plenty of Mac apps that will automatically close when all their windows are closed. And you can replicate that behavior yourself by setting the auto quit to true. And then when all the windows are closed, your app will behave as it does on Windows and Linux. So you have the control over that, and you have to decide what makes sense for your app. But that's how you can manage that setting. All right, file locations. Obviously, different operating systems have things in different places. And the users probably maybe even expect things in different places. So what you're not going to want to do is just assume something's going to be in the same place on all your operating systems, or even maybe even worse, is directly jump through the file system to try and find stuff. Instead, Xojo provides the special folder module, and this gives you access to all kinds of locations, predefined locations. A common one, for example, is application data. And this gives you a pointer to the system folder where apps generally store their specific app data. And speaking of that, so for example, on Mac, that folder would be in the users folder, in the library folder, and then in something called application support. But on Windows, it will be in a completely different location that ends up being called app data, I believe. And I think that's a hidden, and both of those are hidden folders by default on Mac and Windows. On Linux, I forget offhand where it is, but I think it's in the user home folder. And there are many other locations as well. And here it is a sample app that is included with Xojo that you can run that'll show you all the various locations. So you can see here a bunch of locations on Windows. This was running on Windows 10, Windows 10 Anniversary Edition 64-bit. And it probably is a little important to maybe note that these locations can vary by the different versions of the same operating system, and even vary sometimes between 32-bit and 64-bit. So you can see a lot of different things here. Some of them return nil because they're not relevant on that particular operating system. You see many of them have my name in there because that's my user folder and that it's pointing to. So that again will vary depending on who's actually running this. Another good reason why you don't want to directly navigate through a path, because then you have to figure out that username and somehow insert that into the path. So using any of these things will return you a folder item that is pointing where you want it to point, and then you can just use it from there. So that's some of the Windows locations. These are some of the Mac locations. Same sort of thing. You know, many of the locations look similar, but you can see the paths are, of course, different. And then Linux as well. I had to do a couple pages here to get them all to fit. But you can see the same sort of thing. A few more are nil on Linux because they're not relevant. All right, copy file build steps. These are built into the Xojo IDE, and they are a way to let you copy specific files into your app's build. This way your app can easily access them when it's run. So it essentially just takes a file, copies it, alongside your app, so it'll be readily available. And these are separate for each OS target. And when you add one, you give it a name, and you can specify whether it applies to running in debug mode or whether you're building the final version. And probably the most important setting is that where it says destination. And there's a few different locations you can pick there, but the resource folder is generally the common one that you'll use, where you might store things like external graphics or data files or something like that that you need easily access to. These will be copied over by the build steps. In the case of Mac apps, they're copied directly into the app bundle in the resources folder. And on Windows and Linux, there'll actually be a resources folder alongside the app itself where all this stuff will be copied into. All right, the last thing I want to talk about briefly here before we look at a couple quick examples is graphics. And in particular, high DPI is still somewhat new to Xojo. So you want to pay attention to that. We are currently working on wrapping that up for Windows here in the fourth quarter. But you do want to pay attention to differences for that with graphical drawing and whatnot. Take advantage of the image sets that are now available in Xojo, so you can have your different sized images so that you get the best quality graphics when people are using the best quality screens. On Windows, you may run into flicker that can occur in the type of apps Xojo builds for Windows, Win32 apps. And this can be annoying if you kind of ignored it because you were developing on a Mac, and then you go to test on Windows for the first time and you see your Windows stuff flickers a lot. And the best way to mitigate this is to just generally not overlap any controls on top of each other so that the Windows operating itself doesn't try to redraw them repeatedly, causing some sort of flicker. When you're doing your own drawing in canvases and whatnot, there's a few things you can do yourself. The first is to call the invalidate method rather than refresh, and then tell it false so that it doesn't erase the background beforehand. That will greatly reduce flicker. And also the canvas itself has a double buffer property, and you can set that to true. And that will essentially help with canvas drawing because it'll do the drawing off screen before it copies it in to the display, rather than updating everything in the display and maybe causing some flicker. And you can also set the erase background property to false so that it doesn't wipe it entirely, and you end up seeing that little flash that can occur. All right, so I'm going to switch over to Xojo real quick. I just got a couple examples to look at. And the primary example to take a quick peek at is the OK cancel container control example. So you can see here I have a control down here on the window. This is a OK cancel button, which is a control down here that's actually a container. I've just dragged it onto here. And if I run the project, you can see the buttons have now swapped. So they by default say OK and cancel, but because I'm running on OS 10, they've now switched, and the defaults have switched as well. And when I click it, you get an actual event that says you clicked cancel, not that you've clicked a particular button necessarily. And you can see how this is implemented here. There are two buttons on it, of course. And I just happen to call them the left and the right button. And the open event handler of the container is using the target constants to essentially swap the buttons if it's running on Mac. And then if you look at the individual buttons, they also use the constants to determine which button they are. So on Mac, the left button is the cancel button, so it calls the cancel action event. Otherwise, it's calling the action event. And the right button does the opposite. And those events are just event definitions that are specified on the container control, so that when you drag it over to a window, they appear there. And then you can just implement the event handlers as you normally would. So that's how you can design a control that essentially adapts based on the operating system so that it looks appropriate. I just wanted to show this as an example of, again, the target constants being used with a declare, for example. This is a very simple declare. It gets the process ID of the currently running app. But you can see this is how you can create a single method that still can work on all the different platforms and return a value. And in this case, it's declaring into the various OS libraries that return that specific value. So when I run it on OS 10, I'll click it and I get an actual process ID, and things don't crash. And this is sort of thing, little things like this you do have to pay attention to, particularly if you get a little too focused on one platform and maybe put in some declares or other things that just are not going to work on another platform and will cause your app to crash. So you wrap them up like this and you're good to go. And don't really have much to show on this one. This is just the app that shows you all the folder items, special folder paths. And this can be handy to run periodically just so you get an idea of where these locations are on the various operating systems. And you can see nothing super sophisticated here. It's just adding everything to the list box based on the paths. So there you can see. And I also will point out, you can see over here the include in options that are available to include or remove blocks of code based on the platform, or the project type, I guess I should say. All right, that is all I wanted to cover today. Let me switch my screen here to the question window, see if I have any questions. And no outstanding questions. So I think we'll wrap up while we're ahead. Again, if you have questions at any point about this webinar or anything in Xojo really, feel free to email me, paul@xojo.com. Thanks everyone for attending. Have a great day.